all logic is going to deal with a limited range of expression. It's only going to deal with a limited range of sentences, not all the sentences. You never do any logic with questions, for instance. You never do any logic with expletives. Logic happens only with declarative sentences, first and foremost, sentences that purport to, right, whether truly or falsely, purport to describe some state of affairs, describe the way the world is, describe the way the world could be, right? So there's a limited range in all logic. Categorical logic is a very limited range. We only talk about categories of things. We only talk in terms of this category and its relationship to another category. It's right, very limited range. But that makes it kind of easy to organize. Categorical logic is going to deal with 4 sentence types, sorted by quantity and quality. The quantity is going to be either universal or particular. We're either talking about all the members of a category or some members of a category. Some means at least one. The quality is either affirmative or negative, right? So we have an A statement that is a universal affirmative. It says all S are P. S and P here are words standing for subject and predicate, right? All members of the subject class are members of the predicate class. E statements are universal and negative. No subject are predicate. I statements are particular and affirmative. Some S are P. And O statements are particular and negative. Some S are not P. So an A statement is always going to say that all members of one group are also members of another group. We represent that with a Venn diagram quite naturally. Now, notice it's the opposite of like your DVD menus and everything. DVD, whatever, no one uses that. It's the opposite of that, right? Where the shading is like, oh, that's where I am looking. That's where I care about. Shading here indicates where there's nothing, right? The open space indicates where there might be something. For all we know, there's something there. There's nothing there, for all we know. The shading says, hey, there's nothing there. All right, so here's a couple A statements. We got a true one, we got a false one. It'll be represented by a Venn diagram exactly the same way, whether it's true or false. We just have to, use our knowledge to know whether it's true or false. So, all dogs are mammals. Hey, that's true. It's true. All dogs are mammals. And we represent it this way, saying, hey, everything in the dog circle, all the things that go in here, have to be in the overlap with the mammal circle, because all the dogs are mammals. Let me say a little word about homonymy real quick. Are all dogs mammals? Yes, right? If we squint away the ambiguity of our words. Spinoza famously says, actually, dog is his example, right? There's a difference between the dog, the animal, and the dog, the star, right? The dog star. We use these words for multiple reasons, right? We got to squint away the ambiguity. How do we do that? I mean, it's actually a little trickier than we think. But notice there is some possibility of there being a dog that's not a mammal. When we're dealing with logic, right, we need to squint away those details. Honestly, the world is so varied. Our words are so flexible. There's always some ambiguity we need to squint away, right? Whenever we get an absolute truth, like all dogs are mammals, I really think we're squinting away the ambiguity. Now, we can do that, of course, and that gets us truths, but we got to know what we're doing. And here's a false A statement. Still an A statement, right? Still works the same way, still diagrammed the same way. This one happens to be false. All mammals are bipeds. I mean, I'm a mammal, I'm a biped, but not all mammals are bipeds. My cat's out here, you just heard them eating. The cat's out here, they're mammals, but they're not bipeds, right? So this is still how we would say it. This is an A statement with mammals as the subject and bipeds as the predicate, and we'd still represent it this way. But this A statement is false. We do logic with true statements and with false statements. It's about how, right, what we're looking for here in this kind of deductive reasoning, we're looking for validity. We're looking for these sentences get you this other sentence. So here we're still kind of doing grammar. We're still thinking about how do we write well-formed sentences that we can plug in to an argument. And we'll see what those arguments look like in a few minutes. So here's how we would plot all four kinds of statements on a Venn diagram. The A statement and the E statement are universal statements. We plot those by shading to indicate where there's nothing there. So all S are P. We shade the area of S that doesn't overlap with P because all the S's are also P's. No SRP, we shade the overlap because it's saying that the overlap between S and P is empty. There can't be anything there. The particulars, I and O, we diagram by putting an X, right? So our I statement says some S are P. So there is something, there's at least one thing in the overlap between S and P. X marks where that thing is, right? That hypothetical thing that this is talking about that is in the overlap between them, the S that's also a P. Our O statement is particular but negative. It says some S, some member of the S category, is not a member of the P category. So we put an X in the S circle that doesn't overlap with the P circle. So again, shading indicates where there's nothing there, empty. Open space indicates where maybe there's something there, maybe there's not. It's ambiguous. I can speak. The X indicates where there's something. Some S are P, some S are not P.